Hi, Chris Kuzmal here. Today we're going to create a binary search tree again, but we're going to do something that's a bit confusing. 9 is the value of the key of the root node, but the name of the key, the name of the node is 4. Oh my God. Why did I name something whose key value is 4? Key value is 9, 4. Well, it's to illustrate the difference between the value of the key in the node and the name of the variable that is the node. And so the left child of 9 would be 5, and the right child of 9 would be 13 in our example. The assignments that we're going to do is we're going to set the right child of the node whose name is 4 to be the node whose name is 6, but the value of the node whose name is 6 is the key is 13. Oh my God, why is he doing it this way? Well, fundamentally, if you look at the previous video, you'll see that we have the identical same code here over in the left. What I put in different key values. And the reason I put in different key values is now I would like to insert a node whose value is 8, whose key value is 8. All the names of the nodes are the same. So, but now the value of the key being 8 is less than 9. Whoops. And so less than 9, value of the key being less than 9 means that I would insert potentially at the left child. But the left child has children as well. And 8 is more than 5, so I'd insert into the right child. And now here at this node whose key value is 7, it has no children, and therefore I would still insert this. But the name of the node at that location is, I believe, it's going to be node 3, I believe. And so the name of the node is 3, even though the key is still 7, just like last time. And so that's a difference. Let's take a look at the code. So here we have our test find insert methods. We have the test find insert method number 1, which has the code from the prior video. And the expected answer is 7, the node number 7. Here we do the exact same code, except we enter different node key values, even though we have the same node names. And that means that just according as we went through the diagram, that means node number 3 is the node whose name is 3 is the one that is going to be the expected insertion node. Let's look at the find insertion node function for binary trees, okay? So the find insertion node method takes a particular key, which is an integer, and then it creates a return value, which is of type node. So it's going to create a node, and it establishes another node at the root whose name is X. And whenever that node becomes null, then we're going to return the return value, which is a slightly different thing. The return value is saved here on line 13 before we check to see whether or not the key is greater than or less than the key for X. The key that's passed in is whether or not that's greater than the key for X. And if it is, then we set, that is, say, if the key is less than the key at the current node, then we set the next node, the ensuing node, to be the left child. And otherwise, we set it to be the right child. So we're just going down the tree, left or right child, just as we did in our diagrams in our slides before, until we find that there is no child to the node, and then we return the previous node, the parent node, and that then enables us. We can now use this node to insert the node whose key is the argument to this function. So now we're ready in ensuing videos to actually write the insertion method for binary search trees.